Hello students, myself Archana Varude from Praveen Patil College of Diploma Engineering and Technology. Our subject is Applied Physics. Subject code is 22202 and now we are going to start chapter number 1 of Applied Physics, and that chapter name is Properties of Matter and Non-Destructive Testing. And after watching this video, you will be able to understand what is meant by deforming force, what is meant by restoring force, what is the definition of elasticity, what is the definition of plasticity, and what is meant by stress. Here observe these photographs. Here it is observed that when we compress that object, that means when external force is applied, then that body get compressed, and this is the external force. But at the same timing, there is some internal force and which opposes that external force, and it is called as the internal restoring force. And this change in shape and size of body, it is up to when that force is applied. If the force is released, then body returns to its original shape and size. See this second photograph. Here this ball is in its original position, but when we compress it, then it changes its shape and size, and again when we release that, then it returns to its original shape and size. That means the external force which is responsible to change the shape and size of body, that external force is called as a deforming force, or in other words we can say that the force which is responsible to change, that means which is responsible to deform the shape and size of body, that force is called as deforming force, and it is the external force. And opposite to that, there is a restoring force, and this is the internal force. When we apply some external force on object, then here it is observed that due to that external force there is a change. But when we apply that force, at the same timing that object or that body molecules opposes the external force, and that force is called as a internal restoring force. And therefore from that definition is the force which is responsible to regain or to restore original shape and size of the body is called as restoring force. Then what is meant by elasticity? For that we take example of rubber band. When that rubber band it is in its original position, then it has its fixed shape. But when we stretch it, then due to that there is a change in its shape and size. But that change in its shape and size up to when force is present. When we release that force or when the force is removed, then that rubber band returns to its original position. And this is the property of a body due to which it regains its original shape and size when external force is removed. That property of body is called elasticity. Or in other words, we can say that it is the ability of an object or material to resume its normal shape after being stretched or compressed. That property is called as elasticity. And opposite to that, There is another property of body, it's called as plasticity. And for that, here we take two examples. Here these are the two examples of plastic deformation. Here it is observed that here there is a permanent change in shape and size of that bottles. In this another photograph, we take the example of spoon, and here it is observed that this plastic deformation, it is a permanent change in its shape and size. Here it is observed that here this is the permanent change in this spoon, or there is a permanent change in shape and size of that bottles. And here these are the examples of plastic body or plasticity. Here as we know that for clay modeling, clay is used, okay, and when we apply a very small amount of force on clay, for example consider that pin is touched to the clay, then when we touch that pin to the clay, then it makes some hole at that portion, and here when we release that pin or when we release that force, but that hole is permanent, it does not return to its plane surface. Even the force is released, but it does not return to its original shape and size, and therefore this clay is called as a plastic body. And from that we write the definition of plasticity is the property on account of which body easily deforms. That means it easily changes its shape and size, and it does not regains its original shape and size even the force is released, and that property is called as a plasticity. Then what is mean by rigidity? For that, consider example of small stone pieces. Here when we take small piece of stone and when we compress it in our palm, but it is observed that there is no change in its shape and size, and that property of body is called as a rigidity. And definition is the property on account of which body does not changes its shape and size even a large force is applied on it is called as a rigidity. And for rigid body, stone is considered as a rigid body, but in nature no body is called as a perfectly rigid body, because when very large amount of force is applied or when continuously force is applied, then that body changes its shape and size. Therefore, no body is called as a perfectly rigid body. But for consideration, this stone is considered as a rigid body. Then what is mean by stress? Here, as we see that when we apply force on any object, then that force is applied on that particular area, and when we take the ratio of that applied force per unit cross sectional area, that ratio is called as a stress, and therefore from that we write the formula for stress is stress equals to applied force per unit cross sectional area, and in symbol it is written as stress equals to F upon A, where F means applied force and A means cross sectional area. Then we have to write the N case or SI unit of stress. Here formula is F upon A. In numerator force is written and in denominator area is written. Therefore in numerator we write the unit of force, and SI or N case unit of force is Newton, and MK's unit of area is meter square, and therefore SI unit of stress is Newton per meter square, and this unit Newton per meter square is called as Pascal, and it is written as capital P small a. Again we write the CGS unit of stress. Formula is same, that is stress equals to F upon A. But here we write the CGS unit of force and CGS unit of area, and therefore in numerator its unit is dyne for force and centimeter square for area, and therefore CGS unit of stress is dyne per centimeter square. Now we solve some MCQ on these PPTs. First question is SI unit of stress is. Option A is Newton per meter square. Option B is dyne per centimeter square. Option C is no unit, and option D is both A and B. And as we see in the earlier slide that MK's unit of stress is Newton per meter square, and therefore correct option is A, Newton per meter square. Second question is rubber is an example of. Option A is plastic body, option B is elastic body, option C is rigid body, and option D is none of these. And as we know that when external force is applied on rubber band, then it elongates, but when force is released, then it again returns to its original shape, and therefore rubber is an example of elastic body. Therefore correct option is B. Question number 3 is stone is a. Option A is plastic body, option B is elastic body, option C is rigid body,